Hi, welcome to Data Structure and Algorithm series by Coding Ally. Coding Ally is a non-profit organization where we believe women and gender minorities should have a safe space and support system where they can foster their skills and careers in tech. I'm your host Sue. Today, we are solving this Leetcode problem. 203. Remove linked list elements. This is the agenda. First, I will read the problem statement. Then I'll go through the thought process, followed by step-by-step implementation of the thought process in both JavaScript and Java. I will read the problem statement. Given the head of a linked list and an integer val, remove all the nodes of a linked list that has node val equal to val and return the new head. Let's have a look at the example 1. In here, we have got this linked list. 1, 2, 6, 3, 4, 6, 3, 4, 5, 6. From visual observation, we can see that these are the two nodes that we need to remove. So after removing it, this is the linked list that we have. And the head is still 1, but we have removed 6. So in this example, example 2, there is no element in the linked list, so the output is the empty linked list. This example gives us an edge case to consider. What if there is no head? In this case, we just simply return the empty linked list. Next, in example 3, all the linked list nodes have the value 7, which is the value that we need to delete. So in this case, we just simply return the empty linked list. So for the constraint, the number of the nodes in the linked list is in the range between 0 and 10 to the power 4. And node value, it's between 1 and 50 inclusive. The value itself, the value that we need to delete, the value range is inclusive 1 and 50. There are two approaches that we can use to solve this problem. In this video, recursion and iterative using Sentinel or dummy node. In this video, I will focus only on the iterative approach. Before we start, let's think about how linked list is stored in the heap memory. This is the memory allocation diagram. In here, you can see the stack memory is smaller compared to heap memory, and it is fixed size. Stack memory is used for storing the variable, recursion, and control jump. Linked list here, it is a dynamically expanding data structure, and it is not stored contiguously in the memory. And this is one of the key advantages of linked list over array. So in here we can see that, so this is the linked list example given, but this is actually how the linked list is stored in the memory address. So we've got 6 and 3 will not be right next to 6 because it is not stored contiguously. 6 has got the pointer or address that points to that store the address space. From that address we know that 6 is pointing to 3. So this is how linked list is stored in the heap memory. Next, the concept that I want to introduce is two things: Sentinel node and dummy node. As per Wikipedia, this is the Wikipedia definition about the Sentinel node. As per the Wikipedia definition, in computer programming, a Sentinel node is a specifically node, a design node, used with linked list and tree as a traversal path terminator. In this type of node does not hold or reference any data managed by the data structure. Dummy node, it goes at the front of a linked list. The node is there only to reduce the need for a special case code in the linked list operation. So what does that mean? Dummy node. So why do we need dummy node? We need it to pass the head of the linked list in the function. If you keep changing the position of the head node and you need to return the new head node, the thing that you need to consider is how are you going to return that new head node? So therefore, you need to create a dummy node and make it point to the head and move only dummy node, not the head node. I'll go through the example in detail so that you understand this concept. So In here, we are using the iterative approach. Let's think about generic approach using the generic approach when solving this linked list problem. Things to keep in mind. There are two things that we have to keep in mind. First, use the dummy node to keep the head value if you can. This will help us with the corner case. Second, think one, breaking the connections. Let's say you want to break the connections between 6 and 3, and how you are going to store the value, the node value. So let's start with step 1. In this step, if head is not null and head.val is equal to val, then we have to move the head to head.next. This step is to ensure that we are at the value that is not equal to the given value. If you have a look at this example, it will be clearer. Example 1, 6 is the head node, 6 is equal to 6. This is the value that we need to delete, so we will move the head to head.next. In here, example 2, all the value are equal to the value that we need to delete. So at the end, the head will be pointing to null. So this is step 1. Step 2, two-step, initialize the dummy node and make it point to head, like in here, and we will use two pointer. We will initialize two pointer, previous and current. Assign dummy to the previous, assign head to the current. So starting point, the head is pointing to this current node 6 here. So in here, in the step 3, we will check current. While current is not null pointer, means we are going to go through every single node until the end, and we are going to compare. If the value current of val is equal to val, if they are the same, we need to delete it. So how do we delete the node in the linked list? We need to skip it. So we will move the previous to the, we will make the previous point to the current or next. So this way we are skipping, and then after that we have to move current to current or next. So this is how it's done. In here, the value that we want to delete is 6. So 6 and 6, they are equal. So we make previous, make it point to current or next, and then we will move the current. We will move the current to current or next. So in here, 3 and 6, they are not the same. So we move both previous and the current. So after we move, this is where we are now. So we will check 4 and 6. 4 and 6, they are not the same. Again, we will move both pointer, and currently pointer is at 6, head at 6. So 6 and 6, they are the same. So again, we will skip it. So now finally, current is at null. So we are at the end of the linked list, and we will return it. This is the step 4. Okay, let's go through the code line by line. Let's implement step 1. In the step 1, we have to keep going until the head value is not equal to the value that we need to remove. So this is the while loop. This is what it's doing. While head is not equal to null and head of val is equal to val, we will move the head equal to head.next. Step 2. Step 2, we will first initialize the dummy node, and we will create the dummy node, and we will make this dummy node, dummy.next, make it point to head, and then we will create another two pointer, previous and current, make it assign dummy to previous, assign head to the current, and then we will implement step 3. In this step, we are checking every single node in the linked list, and we compare while we are going through that. When we compare, if the values are the same, we will make the previous .NET point to the current or next. This way we will skip. Otherwise, we will move the previous to the current pointer because we don't need to skip it. By the end of, and then once we finish if and else block, we will move the current to current or next. So the reason we have to move the current regardless of if and else condition is that we have to check every single node. So therefore we bring this current equal to current or next here, like so here. So step 4, we are returning the head. So let's discuss time and space complexity. the space complexity we have in here, as you have seen, we only create the dummy node and then we use the 2 pointer. They all take up constant space. So in terms of space complexity O of 1, in terms of time complexity, we go through every single node in the linked list. So the time complexity is O of n. And this is the Java code. Java code concept is also exactly the same, so I won't go much in detail. First is step 1, we will check for the head it's not null and head dot value. If the value is the same, we will simply move the head node. This is step 1. This part is step 2. We will initialize the dummy node, make the dummy node point to the head. We will use 2 pointer, previous and the current, list node previous, assign dummy to previous, assign head to the current. Step 3, we check every single node in the linked list. If the value are equal, we make the previous point to the previous dot next point to the current dot next. We skip, otherwise we move previous to the current node, and then after that we will move the current node, and then this is step 4, we will return the head. So let's summarize what we have learned so far. 3 things that we have learned. First, memory allocation, stack and heap space, how linked list is stored in the heap memory. 2, what is the Sentinel node, dummy node, the importance of them, and then step-by-step approach iterative approach to solve this particular problem. So thanks for watching. Please make sure to subscribe and press the like button if you find this video useful. Join our weekly and fortnightly Wednesday Data Structure and Algorithm Night, where we organize peer-to-peer coding interview. You can find the event details in our Facebook page. Thank you.